Because of the type of material that we are processing, it produces a very high abrasive type of dust when cut. Because of the type of machines that we were using, they have a lot of exposed working parts, and with those working parts they wear considerably with the dust. So we were presented with a problem.
From an efficiency point of view, the dated machines that they currently had were a lot slower. Along the way they've lost accuracy, needed more routine maintenance.
We could see that the robotic arms were actually being used with a routing attachment on the end of them. We started to understand robotics and then quickly decided that's the route we wanted to go down.
Carbolite were looking at a robot solution, and that's where we got involved. We put a solution together between the two businesses.
The question was always about CAD/CAM, and I said, well, do you work with CAD/CAM? We said, yeah, of course, we program robots with CAD/CAM all the time. Already being quite a heavy user of Alphacam, they said, can we keep our existing programs and existing software and integrate it into your new machine? There are quite a few challenges that need to be overcome, and one of those was essentially simulating the robot environment correctly.
So the solution that came together was they could put their parts into Alphacam, they could simulate it in Robot DK, and then the output from that file would then be able to be loaded onto the robot, and then the robot can process that and cut the parts.
In essence, they're taking their existing systems that they've got and redeveloping them into the robotics world.
I was in direct contact with CNC Robotics, did a lot of liaison with Nick and Jason's team. And literally we brought engineers into CNC Robotics. Nick's team helps us to integrate between Alphacam, Robo DK, and then test cut parts, which did take time. But we decided that the time's better taken here rather than use that time on the customer's site. So pretty much we could plug the machine into the facility, and it was more of they can plug it in and everything's ready to move forward cutting parts, which really worked well.
The whole solution, because we were very much trying to buy a solution rather than just buy a robotic arm and software to operate it, it was a whole solution together. Within that desired solution, we can see many benefits. Health and safety reasons, we've got a contained cell, so therefore any dust that is emitted, it's drawn out from the cell. The cutting speeds are far quicker on the robot than they would be on the flatbed router.
So the robot themselves can move 2 meters per second, which is rapid. But they had a significant improvement from their original process, which was very slow.
In some circumstances, the products that we are producing, i.e. that cutting of that material and the type of thing that we want to cut out, can be indeed in sometimes 8 times faster. It's a step forward, and it's future-proofing, because the robot in itself, within the way it can work and the dexterity of it, will allow our designers to be able to design things in a different way and possibly have better ways of forming the insulation in the future.